So we were talking about rotation and translation, and I have given a question, right? क्या question दिया था? What is the last question that we discussed? Already 2 cylinders. एक के नीचे एक, right? एक के नीचे एक है. पूरी क्वेश्चन में थोड़ा कंफ्यूजन हो रहा है. So what you have to remember is the difference between the normal NLM wala procedure and rigid body dynamics wala procedure. NLM वाले procedure में क्या होता है कि pulley is ideal. So यहाँ पे टेंशन T होएगा, यहाँ पे टेंशन T होएगा, यहाँ पे टेंशन 2T होएगा. Ideal pulley. And यहाँ पे टेंशन T1 होएगा, यहाँ पे टेंशन T2 होएगा और यहाँ पे टेंशन T dash होएगा. This is not an ideal pulley. Okay. So this is the thing that you have to remember, and never ever write T dash is equal to T1 plus T2 because the pulley has some mass. So I have not even attempted to write the relationship between T dash, T1 and T2 because I know I won't be able to do it because the pulley has mass, there will be some acceleration. But depending on whether the pulley is going up or down, there will be a relationship between T1, T2 and T dash, which you can find out, which you can write, of course. There's not a big problem, but it is not as straightforward as when we were dealing with ideal pulleys. Okay. The next thing that you have to remember is that यहाँ पे तो summation of force on the pulley was 0. That's it. End of story. But here, neither the summation of force on the pulley is 0, nor the summation of torque on the pulley is 0. So summation of forces is not equal to 0 on the pulley. Summation of torque on the pulley is also not equal to 0. Right? And the final thing that you have to remember is that T2R, T1R, these are the two torques due to the two tensions on the pulley with respect to the center of mass of the pulley. So which to take positive, which to take negative. जैसे ये रोटेट कर रहा है, सपोजिंग आपने यहाँ पे कोई मास है और आपने बोला ये नीचे जा रहा है, ऑब्वियसली ये क्लॉकवाइज रोटेट करेगा. तो इस केस में क्लॉकवाइज जो है वो पॉजिटिव हो जाएगा और एंटी क्लॉकवाइज नेगेटिव टॉर्क हो जाएगा. सपोजिंग आपने बोला कि नहीं नहीं यहाँ वाला ब्लॉक नीचे जा रहा है, तो उस केस में इसका रोटेशन एंटी क्लॉकवाइज हो जाएगा और उस केस में एंटी क्लॉकवाइज you will take as positive, clockwise you will take as negative. Right? Okay, this is how to deal with pulleys with mass. Okay, chalo. I'm going to change the slide. Please take a screenshot. Okay. So one more question for you here, and we move on to the next part of the chapter. This is an ideal pulley. This is a cylinder. System is used if no slipping occurs. Find acceleration of M. Okay. To start you off. हाँ मेरी आवाज आ रही है ना क्लियर? So to start you off, I'll tell you three things. Okay? Three things. First is that I notice in the problem that the block of mass small m is going to execute translation. Right? So I'm going to write F is equal to ma equation. The second thing is that the cylinder is going to execute translation plus rotation. So I'm going to forget about the rotation and I'm going to just write the translation equation for the cylinder, and then I'm going to forget about the translation and I'm going to just write the rotation equation for the cylinder. The third thing is that since the upper pulley is ideal, okay, since the upper pulley is ideal, therefore tension on both sides of the pulley in the string will be the same. Okay? Tension will be the same on both sides of the ideal pulley. And one other thing that you will have to use, which you should be realizing, is that the acceleration of this point and the acceleration of this point must be same in the sense कि अगर ये point a acceleration से ऊपर जा रहा है, ये वाला point a acceleration से नीचे नीचे आ रहा होगा. Why is this? Because these two points, they are connected to each other by a string, and we know that the length of the string cannot cannot change. Okay. So using these four things, number one, a block of mass m executes translation. Number two, cylinder executes translation plus rotation. Therefore, इसके लिए दो equation लिखने पड़ेंगे. Number three, since the pulley is ideal, the tension on both sides will be same. And number four, the two big red dots that I have drawn must have the same acceleration. Magnitude. Direction the opposite रहेगा, but the direction, but the magnitude of acceleration of both must be same. Please do it very slowly. Think about what you are doing. Write each equation. Understand each an equation. हाँ, दोनों masses का acceleration different होगा. Yes, yes. Never assume the same acceleration unless, of course, you are absolutely sure कि दोनों का same acceleration होगा. और अगर आपका assumption गलत है तो end में a1 is equal to a2 आ जाएगा, कहानी खत्म हो जाएगी. That's okay. नहीं, रेड डॉट्स का सेम है ना, लेकिन इसका जो सेंटर ऑफ मास है सिलेंडर का तो इधर है ना. The red dot on the cylinder will have a different acceleration as compared to the acceleration. हाँ बिल्कुल, ट्रांसलेशन भी हो रहा है, रोटेशन भी हो रहा है. इसीलिए जो ब्लू डॉट का एक्सेलरेशन होएगा, दैट इज द acceleration of the cylinder, right? That is the acceleration of the, हाँ 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 एग्जैक्टली वही स्टेप्स है। हाँ एग्जैक्टली वही। हाँ आंसर है, नहीं नहीं नहीं, आंसर बहुत अच्छा है। Yes, almost right. Let's assume that this is going with A1. Let's assume that the center of mass is going with A2. नहीं, इसमें ये गलत है क्योंकि आपका न्यूमरेटर गलत है। आप देखो न्यूमरेटर जो है वो डायमेंशनली इनकरेक्ट। Okay. So if we talk about the translation of M, right, that is tension T upwards, mg downwards. Therefore, we must have T minus mg is equal to ma1. Right? Take equation. Now, if I talk about the translation of M, इसके ऊपर मैं क्या प्रोसेस कर रहा हूँ? T mg, देखिए मैंने arbitrarily assume किया है कि वो नीचे जा रहा है, जरूरी नहीं. You can assume both acceleration to be upwards as well. It will not matter. So this will be mg minus t is equal to capital M. I hope यहाँ तक सबके आंसर मैच हो. Then we come to the rotation of M. तो अब जो मैं फ्री बॉडी डायग्राम बनाऊंगा उसमें यहाँ से ऐड करेगा, mg यहाँ से ऐड करेगा. So I will have tr is equal to IF. And I'm very lucky because I only have one torque. Therefore, I don't have to bother about the direction. Okay. Now let's look at the constraints. So the center of mass of this has acceleration a2 downwards, and because there is only one torque, it must produce an angular acceleration clockwise. Therefore, the acceleration of this point due to translation must be a2, which is the same as the center of mass, and due to rotation, it must be equal to r alpha like this. Therefore, the net acceleration of this point must be a2 minus r alpha downwards. Moment of inertia है अथर. कहाँ हो आप? तो सही है. Moment of inertia into alpha is equal to torque. याद है? So this acceleration must be same. So I get a1 is equal to a2 minus r. Right? Please notice that ये ऊपर की तरफ है और ये नीचे की तरफ. अगर आप इसको ऊपर की तरफ लेते हैं तो ये वाला acceleration is equal to minus ये वाला acceleration. I hope the logic behind that is clearly understood. The logic is that the two big red dots must have equal and opposite acceleration. Okay, so now I have four equations to solve. I want to find the value of A1. So what I'm going to do is that I'm going to sort of put everything in terms of A1. So I have T minus mg is equal to ma1. T minus mg is equal to ma1. Now I want to write the second equation, mg minus. विजय नीचे m minus m नहीं आ सकता है, बिकॉज अगर दोनों इक्वल हो गए तो आपके टर्म में प्रॉब्लम आ जाए. ऊपर वाला फैक्टर आपका सही है. So T minus mg is equal to ma1. पहला इक्वेशन लिख दिया. Now I want to write mg minus t is equal to ma2. So I will write it like this. mg minus t is equal to m into a2. Now I don't want to write a2. I want to write a2 in terms of a1. Right? Unfortunately, I cannot do that. Because अगर मैं a2 को a1 के टर्म में लिखूंगा तो उसमें अल्फा भी आ जाएगा मेरे आंसर. तो realizing the fact that a2 minus r alpha is equal to a1, what I do is I keep a2 here. I don't disturb it. I'll tell you the logic in a moment. And here I am going to write tr is equal to I alpha, which is mr square by 2 by alpha. So if I add these two equations, if I add the two bottom equations, right, t is going to go away. But I don't want that. I want A2 and R alpha to go away. Okay. So what I'm going to do is I'm going to take this 2 that I have here in the denominator, and I'm going to shift it here. Okay. So I'm going to change the slide. Please take a screenshot. I will change the slide. Please take a screenshot. Okay. So we have T minus mg is equal to ma1. We have mg minus t is equal to ma2. And now we have 2t is equal to mr alpha. And I know that a1 is equal to a2 minus r alpha. Right? So there are two possibilities now. The first possibility is कि मैं a1 की जगह यहाँ से वैल्यू रख दूँ. a1 की वैल्यू आएगी t by m minus g is equal to a2 की वैल्यू यहाँ रख दूँ. a2 की वैल्यू आएगी g minus t by capital N और r alpha की वैल्यू रख दो, which will come out to be minus 2t by n. Right? And then what I can do is I can write t by m minus g is equal to g minus 3t by n. Okay, I can take this 3t by m to this other side and g to the other side, and we'll having t, which I can take common now, 3 by m plus 1 by n is equal to 2g. So t is equal to 2mmg upon 3m plus capital M. Right? And I can plug in this value of t to find a1. That is one way of doing it. Other way of doing it is to realize the fact that if I were to subtract the third equation from the second equation, right, then on the RHS I will get A2 minus R alpha, which is equal to A1, which is what I want to find. And I will also end up with minus 3t. So what I do is I multiply the above equation by 3. So 3t minus 3mg is equal to 3ma1. And I have subtracted the third equation from the second equation. So I get mg minus 3t is equal to capital M into A2 plus R alpha, sorry, A2 minus R alpha, A2 minus R alpha, which is nothing but A1. So if I were to add these two equations now, 3t and 3t would go away, and I would get m minus 3m g is equal to 3m plus m into A1. So A1 is equal to m minus 3m g upon m plus 3. So many of you got the numerator correct. I hope the steps are understood. The physics is only up till this point. This, this, and this. चार इक्वेशन निकालने में मैंने फिजिक्स अप्लाई किया. Newton's second law for translation, Newton's second law for translation, Newton's second law for rotation, constraint equation. उसके बाद से केवल सॉल्व किया. now I can ask a question. What should be the ratio of these two masses so that the block does not move? Right? I can ask now the question, what should be the ratio of the masses so that the block does not accelerate? A very weird question. Initially, there was an apprehension कि दोनों का acceleration same होएगा, different होएगा. But now I'm asking a question which blatantly is saying that दोनों का acceleration तो different होगा ही होगा. But आप मेरे को वो ratio बताओ masses का जिससे एक ये जो block है of mass small m ये stationary रहे. Can anybody answer? Very good. Yes. So this is the acceleration we have found. This is the acceleration of the block. And if you want this acceleration of the block to be zero, then all you have to do is, all you have to do is you have to make the numerator zero. And that simply gives you that capital M must be equal to 3 times small m. Okay, and I can ask a similar question, of course. What should be the ratio of masses so that the cylinder does not move, does not accelerate? It will, of course, rotate. वो तो रोक नहीं सकते हैं because torque उस पे एक ही लगा हुआ है. But I can ask this question as well. Okay. So this is all about string constraints. I will give you one more question just to be just for the fact that हम HCV तो attempt करेंगे ही करेंगे ना. ये HCV का question है. If you've already done it, very nice. If you've not done it, let's try to do it now. I will change the data or something. So we have M, we have an ideal pulley with this, and this disc is connected to the fixed ceiling. So this guy has mass M and it has a radius of R. So block is connected to cylinder. If the pulley, मैं पुली की बात कर रहा हूँ, इसकी बात कर रहा हूँ, ये पुली. If the pulley is ideal, find acceleration of the cylinder. Do this question now in exactly the same way. This will involve what we did in the last class and in this class. Same procedure is the same. One of these objects is executing translation. The other is executing rotation plus translation. Right? Please analyze. fully ideal है इसका मतलब ये होगा, be absolutely clear about this, okay? There should be no scope for confusion. ये ideal है इसका मतलब यहाँ पे टेंशन और यहाँ पे टेंशन सेम है, यहाँ पे टेंशन T है, लेकिन यहाँ पे टेंशन T डैश है, okay? अनआइडियल रैप अराउंड, अनआइडियल डिस्क के अराउंड जब स्ट्रिंग जाती है तो टेंशन चेंज हो जाता है। बताओ भाई. So you have to write. हाँ करो आराम से करो. मैं बस वो चीजें लिख दे रहा हूँ जो. अब इतना वैसे मेरे को आंसर नहीं आता है. यू विल हैव टू गिव मी एन आंसर इन टर्म्स ऑफ एम एंड कैपिटल एम. दैट्स इट. जी आ सकता है, नथिंग एल्स. Because remember that T and T dash are tensions which are unknown. हाँ ऊपर टी प्लस. T is equal to MA1. Right? I hope सबने लिखा इसका एक्सप्लेनेशन मैंने assume कर लिया A1. Now I will assume that the center of mass is lying with A2. So here I will write नीचे assume किया है G minus plus T dash. If you have assumed it upwards, it does not matter. You get the answer with a negative sign. Now, for rotation of कैसे rotate करेगा clockwise या anti clockwise as m goes down? Can anybody tell me? अगर नीचे जा रहा होगा तो कैसे rotate करेगा? Very good. Yes. अगर नीचे जा रहा होगा तो anti clockwise rotate करेगा. Yes. This will rotate anti clockwise. So for the rotation of this thing, we must have T dash R minus TR is equal to I. Okay, now look at the unknowns. How many unknowns are there? A1, A2, T dash alpha. There are 5 unknowns. Okay, I will repeat. A1, A2, T dash, and alpha. There are 5 unknowns. But we only have 3 equations. That is why I've written constraints. There will be, 2 constraints here. And it's very easy. The final answer is going to be very easy. And you can sort of and you can sort of remember it आप रख सकते हो, but अगर कहीं complicated problem आ गई तो फिर दिक्कत होगी. So the acceleration of this point and this point must be same. Acceleration of this point and this point must be same. So let me call these points 1, 2, 3, 4. A1 must be equal to A2. This implies that A1 is equal to, थोड़ा सा मैंने confusing कर दिया. Let this be A, B, C, D. What I mean to say here is that AA is equal to AB. Acceleration of point A is equal to acceleration of point B. This tells me that acceleration of point A is A1 and acceleration of point B कितना होगा. तो due to translation तो A2 ही रहेगा. But due to rotation, it will have an acceleration R alpha upwards. So we will have here A1 is equal to A2. Sorry, मैंने उल्टा कर दिया. प्लस मैंने ब्लू एरो उल्टा बना दिया. Because anti-clockwise rotation हो रहा है. R alpha is and since acceleration of point C should be equal to acceleration of point E, we must have ये तो 0 है तो हमें मालूम है. अब acceleration of point C क्या है? Due to translation has to be A2 and due to rotation has to be R alpha. So acceleration here is अभी बताता हूँ. A2 minus R alpha. तो इसमें रटने वाली क्या चीज है? रटने वाली ये चीज है that A2 is equal to R alpha ये तो हमेशा सामने आता है। एंड A1 इज इक्वल टू A2 प्लस आर अल्फा, इसका मतलब हुआ A1 इज इक्वल टू 2R। अब मैं इसमें पहले आपको शॉर्टकट बताता हूँ, फिर मैं बताता हूँ कि हाँ एक हाँ, so first I'll tell you the shortcut and then I'll tell you how I got A2 and R alpha in those particular conditions. Please take a screenshot of this. हाँ जी, so here is the shortcut. अगर ये रोटेट एंड ट्रांसलेट कर रहा है, it is rotating and translating, so its acceleration is A and its angular acceleration is A. Right? It can be like this as well. A alpha. अगर ये ट्रांसलेट एंड रोटेट कर रहा है, then A will be equal to R. Please notice that this is does not always work. Does not always work. But 99 point, at least in all questions of HC Verma, it will work. I don't think they can ask you a question in mains examination where it will not work. However, in the advanced exam and in the exam that we have, there may be questions, 10% of the questions where this will not work. Okay? Be careful about it. So, अगर आपने इसका acceleration A assume किया है, angular acceleration alpha assume किया है, तो A is equal to R alpha आएगा. इसके अलावा यहाँ पे एक पॉइंट होएगा जिसकी वेलोसिटी 0 होएगी. वो कौन सा पॉइंट होएगा? वो पॉइंट वो होएगा जहाँ पे A और R अल्फा ऑपोजिट है. इस केस में यहाँ पे A और R अल्फा ऑपोजिट, right? Due to translation, acceleration is A, and due to rotation, acceleration is R alpha. A is equal to R alpha, so the acceleration of this point is 0. And diametrically opposite to the 0 acceleration wala point, the acceleration of the point will be twice of A. ऐसा क्यों है? क्योंकि यहाँ पे A होएगा और R alpha same direction में होएगा, and A is equal to R alpha, दोनों add हो जाएंगे, तो ये 2. Here also, if you notice that यहाँ पे A इधर है और R alpha इधर है, और इसके डायमेट्रिकली ऑपोजिट A तो इधर ही रहेगा, लेकिन R alpha भी इधर ही हो गया है. ये पॉइंट का एक्सेलरेशन 0 है, ये पॉइंट का एक्सेलरेशन 2A है. क्या सबको समझ में? हाँ, this is all of this is because there is no slippage. Okay? And I don't think you are ever going to get a problem where there is slippage. Right? Although, हाँ, yes, बिल्कुल अथक, yes. So uh, although there is scope that this will be wrong, but you should, if you have understood what I've drawn here, you should be able to do these questions fairly quickly now. Okay, and let me show you how. तो मैंने आपको क्वेश्चन दिया कि भाई ये ब्लॉक है और ये ब्लॉक एक आइडियल पुली से एक डिस्क से कनेक्टेड है और ये डिस्क से जो स्ट्रिंग जा रही है वो इधर ऐसे. Right, now see how I do this. I assume that the acceleration of this is a. Okay. A1, let's say. And I assume that the acceleration of this is a. Immediately I realize that this point the acceleration 0 होगा और इस point का acceleration 2a होगा. तो इसका मतलब ये a1 equal to 2a होना चाहिए. इसका मतलब ये होगा मेरे पास जो इक्वेशंस आएंगे वो आएंगे t is equal to m into 2a. Okay. mg minus t plus t dash is equal to m. And I will get t dash r minus tr is equal to mr square by 2. So this will cancel out. This will cancel out. And I simply need to now multiply this by 2 so that this becomes 4. And then, so 2t minus t will go away. Minus t dash plus t dash will go away. mg आएगा इधर और इधर आएगा a 4m plus m plus m. So a must be equal to 2mg upon 8m plus 3m. ये शॉर्टकट समझ में आ रहा है सबको जो मैंने किया. अगर एक सिलेंडर या स्फीयर या होलो स्फीयर या रिंग नो स्लिपिंग वाली कंडीशन में है, okay, then if you don't want to sort of remember anymore, right, if you are thinking कि अरे ये तो बड़ा टफ हो रहा है, तो what you can do is the moment you spot these things under conditions of no slipping, immediately write down the relationship between acceleration and alpha as a is equal to r alpha. And there is a guarantee that one point will have 0 acceleration and the other diametrically opposite point will have 2a acceleration. And it is also guaranteed that at these points there will be connected some other things जिनका actually आपका acceleration पता चल जा रहा है. एक का acceleration 0 होएगा जो एक point से connected है, दूसरे का acceleration 2a होएगा जो दूसरे point से connected है. I hope this is understood. Hello.
Yes.
Please take a screenshot. I'll change the previous slide. ये वाला ना रजत. ले स्क्रीनशॉट ले लो। And exactly the same thing will happen. If a rigid body, हाँ हाँ एक मिनट, स्क्रीनशॉट लो ना यार उसका, प्लीज टेक अ स्क्रीनशॉट। कितना याद रखना है, A इज इक्वल टू आर अल्फा, हॉरिजॉन्टल मोशन में है तो नीचे वाला पॉइंट 0, ऊपर वाला 2a, वर्टिकल मोशन में है तो तब देखना पड़ेगा कि राइट वाला 0 है या लेफ्ट वाला 0। सारे केसेस नो स्लिपिंग के होंगे, अगर स्लिपिंग वाला केस जो है वंस इन मिलियन ईयर्स आएगा। आई डोंट थिंक आपके पास वैसे भी आने वाला है, लॉकडाउन के मारे हुए आप लोग, मतलब हम लोग बेसिकली। आगे बढ़ो। जो है क्यों चिंता कर रहा है भाई, जब स्लिपिंग आने ही नहीं वाली, जब ये चैप्टर मैं खत्म करूंगा तो स्लिपिंग वाला केस में बता दूंगा। ओके, अभी हम चिंता ही नहीं करेंगे, अभी हम केवल नो स्लिपिंग वाले केसेस में, अगर मैं नो स्लिपिंग ना भी लिखूं तब भी आप अज्यूम करोगे स्लिपिंग। So exactly the same thing will happen when the rigid body is स्लिपिंग नहीं है तो क्या कर सकता है। हाँ हाँ, जो इट विल नॉट वर्क वाला जो सिचुएशन है वो भी मैं डिस्कस करूंगा। एक क्वेश्चन डिस्कस किया था मैंने जिसमें एक सिलेंडर और 2 सिलेंडर, लास्ट क्लास में लास्ट क्वेश्चन दिया। आगे भी क्वेश्चन आएंगे, बट लाइक आई सेड 20 क्वेश्चन मैं दूंगा तो उसमें 2 क्वेश्चन वैसे रहेंगे। ओके, exactly the same thing if a rigid body is moving on a rough surface. So in this case, friction will be there. अब हमें फ्रिक्शन का डायरेक्शन पता करना है, वो मैं नेक्स्ट क्लास में आपको फ्रिक्शन का डायरेक्शन बताऊंगा। बट द पॉइंट इज that you don't need the direction of friction. You can assume any direction of friction and you get the right answer. मालूम होना चाहिए ये अलग बात है, लेकिन मैं कुछ भी अज्यूम कर लूं काम चल जाएगा ये अलग बात है। So whenever you see an object being pulled or being pushed on a rough surface, there will be friction between the object between the rigid body and the rough surface. और अगर रोलिंग हो रही है, नो स्लिपिंग की कंडीशन है, जो कि रहेगी हमारे लिए, उसमें आप फ्रिक्शन कहीं भी अज्यूम कर लीजिए, कोई फर्क नहीं पड़ता है, आपका आंसर बिल्कुल सही आएगा। राइट, सो लेट्स ट्राई दिस क्वेश्चन क्विकली। सिलेंडर बनाने की मेरी नाकाम कोशिश, ब्लैंक बनाने की भी नाकाम कोशिश, M1 M2 R F, find acceleration of cylinder. If it is being pushed by a plank, all surfaces are rough and there is no slipping. हाँ, दोनों surfaces पर friction है। F1 F2 ले लो। एक्सेलरेशन तो पता ही है ना क्या होने वाला है। अगर यहाँ का एक्सेलरेशन ए है तो प्लैंक का एक्सेलरेशन क्या होएगा? अगर सिलेंडर का एक्सेलरेशन ए है तो प्लैंक का एक्सेलरेशन क्या होएगा? नहीं नहीं, अभी हमने डिस्कस किया ना। हाँ जो, यस, अभी देखो जो मैंने शॉर्टकट बताया। हाँ एग्जैक्टली, यस। अगर प्लैंक का एक्सेलरेशन अगर सॉरी बिल्कुल सही, यस। अगर सिलेंडर का एक्सेलरेशन, हाँ दोनों फ्रिक्शन डिफरेंट है। यहाँ 0 होना चाहिए एक्सेलरेशन और यहाँ 2a होना चाहिए। प्लैंक तो इसी पॉइंट से कांटेक्ट है। Quickly write the questions and tell me the answer. The direction of friction does not matter, but you have to be careful of the fact कि अगर आप प्लैंक पे फ्रिक्शन एक डायरेक्शन में ले रहे हो तो अपर सरफेस ऑफ सिलेंडर पे फ्रिक्शन उसके ऑपोजिट डायरेक्शन में आएगा। दिस इज समथिंग यू हैव टू ट्रांसलेशन ऑफ फ्लाइंग के लिए क्या क्वेश्चन आया था? ये क्वेश्चन सबने लिखा, if you look carefully, there are only 3 unknowns: F1, F2, and A. 3 questions, 3 unknowns. हाँ बिल्कुल सही, यस। अब तो केवल ये इक्वेशन ही सॉल्व करना है ना, पहले वाले इक्वेशन को 2 से मल्टीप्लाई करो और ऐड कर दो, तीनों इक्वेशन का कहानी खत्म हो गई। चलो आई हाँ बिल्कुल सही जवाब, यस। ये बाय द वे आईटी एडवांस्ड क्वेश्चन, राइट? सो you see in this question also the shortcut is working. So I'll stop here. We'll continue this in the next class. And I hope that April question number 40, 47, I think I said, or 48, आपने जो है CV का पूरा कर लिया है. Next class के बाद से you should be able to do more questions. Okay. इसके बाद तो कोई वेरी नाइस, वेरी नाइस। इसके बाद कोई क्लास नहीं है ना? अभी मैं एंड कर दूं ना मीटिंग? इसके बाद क्लास है कोई? क्लास है? यस, नो, क्या कर रही है? नो क्लास, ठीक। चलो, सो I'll end the ओके। चलो गाइस, चलो।